So last time we have started to discuss the standard vapor compression cycle, which is chapter 4, not chapter 4. So we're on track in our syllabus. Not chapter 4 is the standard vapor compression cycle, but the refrigerant we will have to go back with that. Yeah, because I'm just establishing the more important topics, which is the reading of the diagram and and the calculation. Later we'll come back to refrigerants, discussing refrigerant. It's a lot easier not to discuss refrigerant because there's no calculation in that part. What I think what is more important is the diagram and the calculation. So let me pull out this blank page to review you in the standard vapor compression cycle, because it's very famous. It's the foundation of refrigeration system, right? So standard here, standard vapor compression cycle. So my question is, what are the components that are involved in this standard, the basic refrigeration cycle? Can you name some few?
Compressor,
Compressor, what else?
expansion valve,
Expansion valve, ano pa?
evaporator,
Evaporator,
condenser.
condenser. No? Very good. So standard vapor compression cycle is the basic process in refrigeration o sa pagpapalamig. Bakit na-involve ang vapor compression? Because basically, we are compressing the vapor. No, we are compressing the gas. What is that gas? The refrigerant. And what is the refrigerant? The working fluid. Meaning that is the fluid that is traveling or flowing within the system into the tubes, sa mga tubo, no? So sa tubo ng evaporator, papasok sa suction ng compressor. Paglabas sa compressor, mainit siya at mataas ang temperature, no? Kasi mainit nga. At mataas din ang pressure kasi nga na-compress. So yun yung tinatawag na vapor compression. Na-compress yung vapor. And we need to do that para magkaroon ng paglamig at pag-init, paglamig at pag-init, no? So yun yung tinatawag na cycle. Now, to simplify the vapor compression cycle, the refrigeration is like, as in many other things in life, it's like just like a story, no? So every activity of man, lahat ng ginagawa ng tao is like story, no? May start, may end, no? May continuity, may cycle, no? Paulit-ulit, no? So ganun lang, no? Ngayon, to simplify this vapor compression cycle, no, for the understanding of everyone, not only for the understanding of engineering students. So I want to talk about this vapor compression in a very general manner, and I'm considering the audience like everyone, meaning even those who are not studying engineering. Yeah. So how does a refrigeration work, and what is this vapor cycle? So the basic components of this cycle is this. There are there are two components. I may uh, draw, and pardon me for my drawing. Hindi pa ako sanay sa digital pad. Yeah. These two boxes, I want to call these two boxes as, no, let me have this. I want to call these components or equipment as heat exchangers, right? And what is heat exchanger? So it is an equipment or device that allows the heat to transfer from one place to another, or to exchange heat. So the minimum number of fluid is what? How many fluids are involved in heat exchanger? So minimum of two, right? You cannot exchange with one. Now, how do you exchange with one? No, person, one entity. It's impossible. It's impossible. It needs two, right? So I will try to put a name on this heat exchanger. I want to call this as what? I want to call this as condenser. And this one is called evaporator. And it's a lot easier to understand this when you try to see what is the root word, right? For example, condenser, condense, yeah, meaning from vapor to liquid, condense, condenser. When you put the suffix er, that means it becomes like like a person, or like execution, right? Something is happening in the execution or implementation, yeah. Condenser, trainer, yeah. Or er, yeah, that is the suffix, right? Vote, example, vote, voter, yeah. Sabihin tao na bumoboto. Condense, condenser, evaporate, evaporator. No? So these two equipments are doing that kind of process. One is condensing the vapor into liquid. The other is trying to evaporate. No, I mean trying to convert the fluid or liquid into gas. No, evaporation will happen, and then it will have a gaseous state. No, so let me say something about these two equipment. No, I'm trying to emphasize this because this the heart of the discussion. No, so these two are called heat exchangers. Yeah, and heat exchange, heat transfer is a very core part of thermodynamics, wherein heat is moved from one place to another, from one form to another, right? And what is happening in heat exchanger is this. Now, ideally, it is behaving under some principle like constant pressure. Yeah, constant pressure. So I'll repeat, when you try to discuss about condensers and evaporators and coolers and preheaters and so on, wherein the heat exchange is happening, the principle is constant pressure, meaning pressure, look at this, pressure is constant. In the lingo, in the language, in the jargon of thermodynamics, it is called iso, what? Isobaric. Iso means equal, baric, no, baric, not barbaric, but bar, not from the word bar, pressure.
Sir,
Okay, yes,
di po ata nagre-record.
record. Ah, okay. So, sandali. Let me go back. No? Hindi ko yata napindot, ano? Sandali, ah. Sana ba yun? Ito? Yun. More action. Ayan. Start na. Thank you, thank you. So, balik tayo doon, no? Konti pa lang naman yung na-discuss natin. Okay? So now we already click the record button now for the review, no, para ma-review niyo pa ulit-ulit ni record natin yan. Again, no, going back to the initial discussion, we have two equipments and they are called heat exchangers. And heat exchangers are under the governing principle of constant pressure. P equals C. Pressure is constant for both equipment. And when you go to the domain of thermodynamics, This constant pressure is called isobaric. No? It's just the adjective, no? Isobaric. But the term is isobars, no? About isobar lines, constant pressure lines. Iso means equal or constant, bar is pressure. Okay, so we have this equipment. Now, these two equipment have distinct function. Let me discuss that. Yeah. These two equipment are heat exchangers and they have this is distinct function. One evaporator is absorbing heat, no? Q A means Q added or Q in. The others are saying Q L. Oh, what are those? Q A is Q added, Q in I in. Q in is heat is being put inside Q in. QL, what is L? Low. Meaning the heat here is low side. Okay? Because on the other side is the opposite. What are the heat configuration in the condenser? In the condenser, we term this as QR. What is QR? Q means heat. That's the universal variable used in the engineering. R is rejected. Okay? What else? Q, we have low, QL, QH. What is QH? Heat high, meaning heat in the high side, yeah? Because if you are going to put a line that bisects or that divides the two region, the region into two, the condenser side is high side and the evaporator is low side. That's why low QL, high QH. Okay? So, that is the two. And these two are being, no, in between these two, there are other equipment. Now, let me draw. Between the two, because what could what could these two to do to each other? What is the relationship of evaporator and condenser? Yeah, so there should be a link between them. Now let me draw this. Between the two, there is this equipment, and what is this equipment? Compressor, right? Because the fluid in the evaporator cannot go directly in the condenser. It will have to pass, no? It will pass through another component. Now, let me see. Yeah, this is the compressor, right? So this is the compressor, this is the suction, and this is the discharge, right? So let me put this here, okay? So the evaporator, what is happening in the evaporator? It will absorb the heat from the surroundings, meaning the heat of the room, the heat of the vegetables in the refrigerator, the heat of the water in the inside your refrigerator, the heat of fruits, vegetable, fish, and others, right? So that heat will be absorbed by the refrigerant. Where's the refrigerant? Here. The refrigerant in the coil, right? So the refrigerant is not scattered everywhere. It is in the tubes or the coil. So coil is in the evaporator and coil also is present in the condenser. That's why we have condenser coil, evaporator coil. So the refrigerant inside the evaporator tends to absorb the heat from the surroundings. And thereby, when it's absorbed, the refrigerant is being evaporated. So here, when the refrigerant comes out, in the evaporator, it is in gaseous form because the gaseous form is the only form accepted by the compressor, right? The compressor cannot accept liquid, only gas, right? What happens if your compressor will absorb liquid? No, it will break down. It will burst. No, because when you compress the liquid, by theory, ideally, fluids are incompressible. So when you try to compress the fluid or liquid, no, it is not actually being compressed like air. No, like air, it is compressible, but fluid is incompressible. So whatever force or pressure you are trying to impart, it will absorb all, right? Like positive, yeah. It is not changing its volume, so tendency is it will burst. So if you want to put pressure or force on the fluid, no, because you want to do something with the fluid, you are not going to use a compressor. You are going to use a pump, yeah, because pump is for fluid fluid deliveries and fluid transfer, right? Compressor is for gas. I just want to be clear on that. Now the compressor, after it is compressing the refrigerant, what happens is the refrigerant is being compressed, right? So when it's being compressed, the pressure, meaning it will become high, yeah, because it's pressurized, right? The vapor has a high pressure, and according to thermodynamics, ideal gas law, when a system is having a high pressure, something is happening also in the temperature. So the temperature is also becoming high. So meaning when it goes to the condenser, the temperature and pressure is high, right? Temperature and pressure is high. And what is happening in the condenser, there are two fluids involved. One is the refrigerant in gaseous form and also the air. So as you can see from, for example, in the simple refrigerator or air conditioning units, there is this fan or blower that tries to blow air in the condenser, right? So the air blowing in the tubes, the air is colder than the temperature of the refrigerant inside the condenser, right? So when it blows, when there's a blower here, for example, let me put this. When there's a blower here, it will blow air here. So this colder air will try to blow, and then the hotter refrigerant inside the tube will release heat. That's why this QR. That explains why the condenser is put at the back or at the bottom or at the side of the refrigerator. And when you try to stand at the back of the refrigerator, what would you feel? Or if you stand near the back of the air conditioning, your split type air conditioning or box type, right? The basic type of of air conditioning unit, the box type, window type is another name. So we try to stand at the back of the air conditioning unit. What would you feel? You will feel hot air because that is the hot or the heat extracted, no, being taken away from the refrigerant. And when you try to take away the heat from the refrigerant, meaning the absence of hotness is coldness. The refrigerant is trying to change its form from gaseous to liquid. That's why it is condenser. It tried to condense, and it will have a product of or output of condensate. Right. Condensate. So the general term of the output coming from the the exit of the condenser is condensate. Now, meaning the refrigerant is now in the liquid form. How does the liquid go to the evaporator? It is not possible, yeah? Because the evaporator can only absorb a low. temperature and low pressure liquid. So there must be another device that needs to be mounted, and that is the so-called EV. What is EV? Or TXV, thermo expansion valve. This one is expansion valve. No? So from the condenser, it will go to the expansion valve. And the term is only aptly fitted because once the gas expands, what happens to the pressure? What happens to the pressure? So in order for this to in order for you to understand this, now imagine a syringe. You know syringe? You know syringe. When you go to the hospital, there's a syringe. Injection, hiringilya in Tagalog. Syringe, now when you try to put pressure, right, the volume becomes at this point. When you try to pressure, when you put pressure by your hand or thumb, the pressure is increasing, but the volume is decreasing. Okay, and then you can put the maybe blood or others, yeah, vitamins or dextrose and other. Now, what happens when you reverse the process? When you try to expand the volume, use the syringe injection. So here, when you try to pull back the plunger, that element for pushing is plunger. When I try to increase the volume, meaning here, what happens to the pressure? It will relax. Yeah? So the pressure is going down while the volume is going up. Yeah, look at this. Yeah, the volume is increasing. The volume is increasing, but the pressure, is becoming relaxed. Yeah, so that's the relation. We call that as Boyle's law. Yeah, Boyle's law. So here at the expansion valve, that is exactly what is happening. The pressure is going down. The pressure is going down. Okay, the volume is up, meaning expand. Yeah, you know that's why it's called thermo expansion valve. By way of expanding the gases, the pressure is lowered. The pressure is going down because we can only put low pressure in the evaporator. Look at this, yeah? Low side, high side. So before the fluid can enter the evaporator, we need a low pressure fluid, and that is the function of the evaporator expansion valve, sorry, EV or TXV, thermo expansion valve. And what is happening in the thermo expansion valve, that is constant enthalpy because it is adiabatic. Yeah, adiabatic. Now, we will review that when we go to the so-called pH diagram. This is, what is this? Isentropic. Isentropic work, no? Meaning entropy, S is constant. Isentropic work of compression ideally is isentropic. And what thermodynamic properties do we have in this evaporator and condenser? What is constant here is pressure. Yeah, pressure is constant, meaning isobaric. Yeah, isobaric. So pressure is constant in every heat exchanger. Pressure is constant, so iso means equal, bar is pressure, and ik is just the adjective, the suffix for that adjective. Okay, how do we translate this in the so-called pH diagram? Yeah. So this graphical notation or graphical drawing, pictorial drawing is being converted in the pH, right? Ano to? Diagram. And let me explain this very very clear to you. That is my intention for, oh my god, it's hard to draw a line, pardon me. Now, how many lines can we see here? So we can see two lines. Let us call this P and H, meaning P stands for what? P stands for pressure, and H is enthalpy. You should know this, or I presume you very well know this because you have undergone this thermodynamics. You cannot pass thermodynamics if you don't know even what is these lines called, pressure enthalpy diagram. And that is a diagram used mostly in refrigeration system, okay, and air conditioning system. There's another diagram called TS. What is TS? Temperature entropy. Yeah. So S stands for entropy, H stands for enthalpy, and these are the units of energies, right? Enthalpy, then entropy. Entropy is the so-called science of disorder of atoms, right? But there's an energy, heat energy that is associated with it. Enthalpy also has to do with internal energy. You know, the higher the temperature, the higher the enthalpy. Okay, the higher the pressure, the higher the enthalpy. Now, would you know what is the form of this pH diagram in refrigeration system? So the form is kind of like a dome, right? Like a dome. You know what is dome? It is not perfect, but at least it represents. Uh, so it's like a curved dome. If you're studying statistics, it's like a bell. You know bell? Ano ba yung bell? Kalembang sa simbahan. Bell. That's why in statistic, bell curve or Gaussian curve. It's not like a bell, no, or maybe because it doesn't have any sharp configuration at the top. But let me say it's a dome or like a bell, which is skewed. The term is skewed. What is skewed? In Tagalog is nakahilig. No, another term maybe is leaning, leaning to the right, skewed to the right. So, nakapaling, nakahilig sa kanan ay ang ating dome type. Na, and it's the pH diagram. The line here is the pH diagram of the refrigeration. You can study other diagram, pH also. For example, pH of water, pH of others. But here, pH of refrigerant, because we are studying refrigerant here. Now, that's the working fluid of the refrigeration system. Now, if you are going to divide, if you are going to divide this dome into exactly half, you will arrive at this point, the tip, yeah, and we might call this as C, or the others are CP, no, critical point, wherein you could no longer identify whether it is fluid or liquid. And why do we say that? Because this half, this half, I mean this half, no, half left, half left, and this half right of the curve has a significant meaning. This line here is called saturated liquid line. This one is what? Saturated vapor line or vapor curve, because that line is a curvature, yeah. So these are both lines, but one is liquid and the other is gas. So here, if you get a point from here, now for example pressure, the pressure here, right? You can get the pressure of P. You can get the pressure here, right? So you can get the pressure here at saturated at what temperature? Yeah, saturated at what volume, right? So these are called saturated liquid line, and this called saturated vapor line. That is why here you can get the Hg. What is Hg? Enthalpy of gas. Sorry, HF. I am very sorry. HF. Why F? Because fluid, right? You can also get the VG, volume of
Because of water.
sorry, BF, right? VF, yeah, volume of the fluid, HF. So everything is fluid in this. The other half, you can get the G, meaning the gas properties. So here, BVG, volume, specific volume of gas. Or you can get the Hg, enthalpy of gas. No? So the right half is gaseous form, saturated. No? So if you are given a temperature, you can get the properties. So for example, at this temperature, the temperature line is like this, right? So you can have like this, right? Then constant, yeah, then here, yeah. So this is the temperature lines, yeah, right, yeah, here. Those are temperature lines. And you can easily get that from pH diagram because you have this gas, no? So all these are in gaseous form. The other is in liquid form. No, are we clear on that? Ulitin ko, no? I'll repeat. Half, this one, no? All these are in saturated, meaning ano na, saturated na, no? Sagad. Saturated gas. Walang liquid dito, walang liquid, no? Dito naman saturated liquid or F. Wala ditong gas, no? Fluid to, basa, no? Wet. So in between the two regions, meron tayong mixture, kaya meron tayong FG. Okay? Meaning magkasama yung fluid galing dito at yung gas. And they are well explained or well described by the so-called X. Ano yung X class? What is X?
Quality.
Quality. Or the other name for quality is dryness fraction. Ano? Ibig sabihin hindi buo, no? Merong portion na fluid, merong portion na gas. So eto, tingnan mo to. Eto ay 100% ano, gas. Kaya nga saturated, 100% na eh. Dito naman sa kaliwa, ano to? 100% liquid. Kaya nga F, di ba? HF, VF, kasi nga saturated na yung liquid. Kapag tumaas pa siya sa saturated um, property, bawa, tumaas siya ganon. Di ba? Tumaas siya. Yeah? Anong region to? Yan. Anong region yan? Region
Super.
of superheat. No? Region of superheat. Kaya, tinawag na superheat dahil mas mataas siya sa saturated. Okay? Now, ano ang kinalaman ng ng ating drawing doon sa pH, no? So, merong kinalaman. No? So, erase muna ako ha para maintindihan. Erase ko tong nasa kanan para maintindihan lang. No? Uulitin natin yan. Okay, magala. Don't worry. We are going to to repeat the lines of pH diagram, and now we are going to label the components of the refrigeration system as they function or as they perform their role yung mga kanilang mga ano no ginagampanan na 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 role sa refrigeration system. So punta tayo sa pen. uh, ano bang pen natin? Itim na lang. Yan. No? Balik tayo ha. Mabilis lang to. Class, makinig. No? So we have this pH. So this is P. This is H. No? pH. And then we have like a dome type which is leaning to the right. Okay? Yan. So my drawing might not be perfect, but what I'm trying to say is that ganyan ang form, no? So ngayon, saan ba nagsisimula ang process? Okay? So here, pwede naman tayong magsimula kahit saan, because cycle lang naman 'yan, no? So sabi nga natin na di-divide ang vapor compression sa dalawang region. Anong region? Region ng low pressure at high pressure. Maliwanag ba? High pressure, low pressure. Kaya nilagyan ko ng H tsaka L. Ano sa tingin nyo ang may mababang pressure? Evaporator ba o condenser? Ha? Evaporator, di ba? Because evaporator is working under the principle of low pressure, low temperature. No? So, ganito yan. No? So, tinan nyo. Low pressure, so automatic yan, eto yon, no? So, dilagyan ko na ng pangalan, evaporator, no? Kasi nga, low pressure. Ito naman, anong mas mataas na pressure natin?
Condenser.
Condenser, no? Dilagyan ko na ng pangalan to, condenser. Di may dalawa na akong equipment. After ng evaporator, eto makinig ha. After ng evaporator, anong susunod na equipment? Ano?
Pressure.
Compressor, no? So, after the evaporator, look at this. Bakit ko nalalagyan ng bilog yan? Because the evaporator, the function of evaporator is to evaporate the refrigerant. So, at this point, magkakaroon ka ng tinatawag na saturated vapor at this point. At yun ang pumapasok sa entrance ng compressor. So, di ba? And then, there's a curve like this. There's a curve like this. Ano naman to? Compressor. Yung curve na yan, no, yung curve yan ha, papaka-curve yan. Yan yung tinatawag na compression line. At ang nangyari sa compression, work of compression, anong constant dito sa thermodynamics? Constant entropy. S equals C. No? Sa lingwahe ng thermodynamics, isentropic. Ito naman, pressure is constant. Ano to? Isobaric. No? Anong masabi nyo sa nangyari sa pressure? Tingnan nyo ha. Dito, ang pressure ay dito lang, no? Dito, mas mataas. Ano nangyari sa pressure? Pag nakarating na siya rito? Mataas o mababa? High or low? Pressure. Ano nangyari sa pressure? High. Di ba? Kasi nga, kinompress mo na yung vapor eh. Pag kinokompress mo ang gas or vapor, tataas yan, no? Tataas kasi gas is compressible, no? Pag tumaas yung pressure according to thermodynamics, saan na ba itong aking pen, no? Ayan. Pag tumaas ang pressure, ano mangyari sa temperature, class? Tataas ang temperature, right? Tataas din ang temperature dito. Pero ito, tong region na to ay, ano to? Superheated. Yan. Pag pumunta siya rito, dumating siya sa point na to, anong nangyari? Sa refrigerant. Naging uli,
Saturated.
saturated, no? Kaya lang, ito ay saturated na, no? Saturated. Output yan ha, tinan nyo ha, output na yan, output yan ng ano ha, ng compressor ha, superheated, saturated, punta siya sa dito, ano ba to? Ito yung entrance. Anong entrance? Ng
Condenser.
condenser. No? So yung condenser is ganito lang po. Yan. Ito yung evaporator. Yan. So ngayon, meron na tayong entrance ng condenser, galing siya sa exit, no, output ng compressor. Hanggang dito siya. Ano ang trabaho ng condenser? Ang trabaho ng condenser ay mag-reject ng heat, heat reject, no? Ito naman is mag-add or magpapasok ng heat, Q in, Q out. Q in, Q out. Pag dumating na siya sa punto na to, ang tanong ko, ano ang punto na to? Ito ba ay fluid, ito ba ay gas, o ito ba ay mixture ng refrigerant? Ano to? Ito
Mm.
ay fluid. Bakit? Ito nga, itong line na to, di ba? Sabi ko, ang half left ay fluid. Ang half right ay gas. No? So, dito, fluid siya. Mataas siya na pressure o mababa? Mataas. Ayan o, P, high. Mataas pa. Ang mababang pressure ay ito, P, low. Ang tinatanggap lang ng evaporator ay mababang pressure. So, kailangan natin ng isa pang device para mapababa ang pressure. Ano yun? Ano yun, class?
Expansion valve.
Expansion valve. When the gas expands,
Bababa pressure.
bababa ang pressure. Pero yung volume luluwag, lalaki, 'di ba? Kasi gas nga 'yan eh. Kanina sa compressor, kabaliktaran ng expansion valve, pinipi mo, kinompress mo yung vapor. Kaya tumaas yung pressure, at pag tumaas ang pressure, tataas din ang temperature. Ngayon naman, baliktad na nangyayari. Pinababa mo ang pressure dahil sa expansion, no, may mga tinatawag na ano diyan, mga orifice. Due to the differences in diameters, na may mga nagbabagong mga diameters diyan, bababa ang pressure kasi yun ang trabaho ng expansion valve. So ang expansion valve ay nagbe-behave na constant enthalpy. Ano yung constant enthalpy? Diretso lang. Diretso lang, no? Diretso lang. 'Di ba? Tingnan niyo, ito enthalpy 'to, 'di ba? H. Pag diretso yung enthalpy, diretso yung enthalpy, ibig sabihin, ito, pareho lang yan na enthalpy. Ito, di ba? Going down, the enthalpy is constant. Why? Because if you look at this, no, vertically, pareho lang. Tingnan niyo yung pressure ha, ulit-ulitin ko. Mataas ba ang pressure dito? Mataas. Pababa, pababa, pababa ang pressure, bumaba ang pressure. Nagbabago ba ang enthalpy? Nagbabago ba ang enthalpy, class? Oo, hindi. Hindi. Yan, 'di ba? Diretso lang 'yan. Halimbawa, ito yung enthalpy mo, sabihin mo, ito lang, no? Ang enthalpy ko ay 100. Dito naman ang enthalpy ko ay 300. Oh, hindi naman nagbago, 'di ba? 100 yan, bumaba ang pressure. 100 pa rin yan, bumaba ang pressure. 100 pa rin yan, bumaba ang pressure. Hanggang dumating sa punto na to na 100 pa rin ang enthalpy halimbawa, pero no, hindi nagbago enthalpy, pero ang pressure ay bumaba. No, nagbumaba kasi nag-expand nga eh. Nag-expand nga yung gas kaya bumaba ang pressure. Ngayon, gagamit ako ng another color para mas maintindihan, no? Anong forma naman? Anong state? Ito. Para maintindihan. Anong estado to? What is the state of this? Ano ang form nito? Wala siya sa linya. Ito liquid eh. Ito ano
X.
to? Anong forma nito? Anong state? Gas.
X.
O nasa pagitan siya ng liquid at ng gas. O ano siya? Mixture, no? FD
Mixed
siya, di
vapor.
ba? Oo, mixture ng vapor. It is between the vapor and the liquid. Kaya ito, FG. So, same as this, no? So, FG, 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 FG. You know? May mixture siya ng vapor tsaka gas. Okay? Maliwanag ba? So, ang ganito ay mixture ng vapor at gas. Ngayon, buburahin na naman natin, no, para malinaw. Total, naka-record naman to. Gusto ko lang malinaw kung ano nangyayari. What is happening in the pH diagram, I would like to make it very clear. That's why when we go to the calculation, whether in when in refrigeration or air conditioning, the concept is clear. Now, the foundation of refrigeration engineering is crystal clear. No? Kahit na pag malinaw sa inyo kahit na anong problem ay masasolve nyo. Ngayon, okay na tayo rito? No? Burahin ko rin to para malinaw. No? Kahit ito lang yung ma-take up natin ngayong araw na to. No? Basta malinaw. And then sa Lunes, no, sabi ko nga, ipapasa yung mga assignment, di ba? Nasa video naman yun, nilagay ko na sa YouTube, sa channel natin. So, walang problema. Ang gusto ko lang mangyari, no? Kasi yung solving naman is mathematics lang yun eh. Ang mas mahalaga sa akin ay naintindihan ng sinusolve, no? Kasi yung mag-math pipindutin mo lang naman sa calculator yon, no? Ang gusto kong mangyari ay naintindihan ang ginagawa natin, no? So, eto. Ulitin ko to, no? Naka-eraser mode pa ako. I'll try to get a pen here para tuloy-tuloy na tayo. Right? Yeah. Eto, balik tayo rito. Meron tayong dalawang equipment. Ang isa ay nag-absorb ng heat, ang isa ay nagre-release ng heat. Anong tawag dito? Evaporator. Ito, condenser. Okay? So, ito ay anong tawag dito? Photographic or picture diagram. Ito naman ay yung tinatawag na pH, no? Ito ay pictorial. Ito ay may valvula, sabihin natin ganyan yung valvula, yan. Tapos pasok dito sa evaporator. Itong evaporator paglabas gas na yan, no? So yung gas na yan ay i-compress ng compressor. Papasok dito, pagkalabas niya papasok sa condenser, evaporator, okay? At ang condenser ay may coil, ito naman ay may coil, ito naman ay may piston, di ba? May piston, tsaka piston rod. Kaya ganyan yung itsura. May suction tsaka discharge, no? Piston rod. Ito coil. Walang piston rod dito sa evaporator Baka nag-aaral kayo ng engineering, sasabihin niyo may piston. Ang piston lang ay sa engine or makina ng compressor. Okay? Evaporator, condenser, compressor, expansion valve, EV or TXB, no? Ito ay expansion valve. Ngayon, mayroon tayong dome na naglilin sa kanan, no? Skewed to the right. Ito ay, ano to? Evaporator, no? Ito ay compressor. Pag tumama dito sa fluid, no? Yan. Condenser. Pag pababa, anong involved dito? Constant enthalpy, ano yun? Expansion valve. Okay? Now, gagamit ako ng isa pang kulay. Total, libre naman yung iba't ibang kulay rito para lang mag-contrast. No? Yan. Sabihin natin ang evaporator ay E, no? Siyempre E, no? Gusto ko katulad ng first letter, no? Sa dito. Evaporator ay E. Halimbawa, E. Papunta siya sa A. Saan 'yon? Yung E. Ibig sabihin yung E, yung evaporator daw ay hindi. Dito pala yung E. So yung E is evaporator, yung start ng evaporator, yung dulo ng evaporator, yun din ang entrance ng compressor, 'di ba? So A to, no? A din 'yan, no? Saan yung compressor? Ito A. Okay? Nakikita ba, class? EA. Ang dulo naman ng compressor ay tatawagin ko na B. Yun naman ang papasok sa condenser. So saan 'yon? dito, no? So paglabas sa compressor ay superheated. Ibig sabihin, mas mataas siya sa saturated. Saan yung saturated? Ito sa A, di ba? Kasi vapor na nga eh, vapor. Ito di ba vapor? Etong kalahati nito ay vapor. Ito ay liquid, F. Ito ay G, no? G na region, ito ay F. Pagpunta niya dito sa mga region na to, no, region na to ay superheated, no? So meron tayong mga ano diyan, na temperature lines, right? Temperature lines 'yan. Ngayon, yung B, ano naman to? Pwede kong tawagin to na C, na para lang maganda ang ating notation. Pati naman, A, B, C. Saan yung C dito, class? Entrance ng
Denser.
condenser. No? Saan yung entrance ng condenser? Ayun, no? Saan ba yun? Ito, no? Condenser ay C. Di ba? C to. C. So, B siya. Ito, B. Pagdating dito sa point na to, no? Anong letter to, class? Sa point na pumasok sa condenser, anong, letter?
C.
C. Di ba? Paglabas niya sa condenser, dito, pag lumabas sa condenser, fluid na siya. Bago pumasok sa expansion valve, anong letter to? A, B, C, ano to?
D.
D. Saan yung D ko? Doon sa saturated liquid. Yan, o, D. O, ulitin ko. Saturated vapor sa A. O, makinig ha, A. No? Vapor. Kasi hindi naman pwedeng pasukan ang compressor ng liquid. So, dapat vapor, saturated vapor. So, G, no? Kaya meron ka diyang VG, SG, HG, no? Gas. Saturated gas or vapor. A. Paglabas niya, lampas siya doon sa fluid, no? Kasi ito ay region ng, anong region to? Super heat. So, from superheat, class, babalik siya para maging saturated. Di ba? Vapor. Vapor. G. Yan, no? Ano nangyari dito from B to C? Ano nangyari sa process na de-superheat? No? So, there is a process called de-superheat. Yung na ano na naalis yung pagiging superheat niya, bumaba yung energy niya, bumaba rin yung temperature, pero constant ang pressure. No? Tingnan niyo yan, constant ang pressure, pero bumaba yung internal energy niya, which is the enthalpy. Tingnan niyo enthalpy, no? Ano nangyari sa enthalpy? Bumaba, di ba? From here, look at this. No? Ito project ko lang. Ito yung enthalpy ng B, di ba? H, B. Ito, ano to? Anong enthalpy to, class? H sub A. Ito, H, E. Pwede nating tawagin na ito ay enthalpy 1. No? Yung enthalpy 1 mo nandun sa start ng evaporator. Mababa pa yan kasi mababa naman yung pressure at temperature ng refrigerant sa evaporator. Tataas yan, no? Papunta doon sa entrance ng compressor. Pwede nating sabihin na H2. Okay? Pag kinompress siya, lalo pang tataas yung pressure at lalo pang tataas ang temperature. So, pwede nating sabihin, gawing notation to ay H3. Kaya ba na kunin ang H1, H2, H3? Can we get the H1, H2, H3? Kaya. Yung H2, madali, di ba? Kasi saturated vapor, no? Di ba? Makakuha ka dito ng Hg, di ba? Given the pressure. Siyempre, bibigay yung pressure dito, di ba? Sa problem, the low pressure of the refrigerant or the refrigeration system is this, no? Halimbawa, ito ay sabihin mo is mag-invento na lang tayo for the sake ng 10 kilopascal. Tapos ito mas mataas, no? Tingnan niyo yung pressure, tumaas. Sabihin mo 100 kilopascal, no? So pag binigay ang pressure, hanapin mo 'yan sa pH diagram, pressure, no? Saturated kasi constant lang naman yung pressure no? Constant ang pressure diyan. saturated pressure at saturated pressure of 10 kilopascal, makukuha mo yung enthalpy, no? Enthalpy of gas, volume of gas dito. Okay? Dito makukuha ba? Pwede, no? Kasi dito makukuha mo yung tinatawag na entropy. Ayun, no? Constant entropy. Yung linya na to ay S equals C, meaning entropy is what? Constant. Pareho lang. Habang ikaw ay bumabagtas dito sa linya na to, constant entropy. So meron kang constant entropy, di ba? Line. Meron ka dito na, ano nakuha mo dito? Enthalpy. May volume of gas ka. No? Makukuha mo doon yung entropy ng 3. Entropy at superheat. Okay? Ngayon, dito, makukuha mo ba dito yung enthalpy? Makukuha mo sa D. Kaya bang kunin class? Dinidiscuss natin yung ano, yung pH na ngayon ha. Kaya bang kunin dito? Makukuha mo ba yung enthalpy dito o hindi? Ha?
Makuha.
Makukuha kasi meron kang nandun ka sa saturation line, di ba? Kasi naging fluid ka na eh, di ba? Ang entrance mo sa expansion valve ay fluid. Ito, yung linya na to, sabi ko ay F, no? So sa fluid, bibigyan ka ng pressure. Ito nga, halimbawa, the high side. Ang mga ano diyan class, ang mga description ay the high side temperature, the high, ito the low pressure, or the pressure the operational pressure is between 10 to 100. Alam mo na pag 10 mababang pressure ay evaporator. Pag 100 mas mataas ang pressure, high pressure, condenser 'yon, no? Evaporator, condenser. So malalaman mo kung ano yung range ng pressure. So pag may pressure ka dito at saturated naman to, ibig sabihin P-sat, no? P saturated, halimbawa 100 kilopascal, saturated pressure at 100 kilopascal, makukuha mo to yung mga F, di ba? May volume, specific volume of fluid, meron kang enthalpy of fluid, meron kang entropy, fluid, no? Entropy of fluid. Dito naman, makukuha mo sa gas, no? Kasi saturated nga yan eh. Makakuha ka ng SG, makakuha ka ng VG, makakuha ng HG, no? Kasi gas nga yan, no? Dito naman, makukuha mo kasi may constant entropy ka, no? This line, ito yung inaano ko, no? Pinapaulit-ulit ko, ay constant entropy line. Ibig sabihin, may constant entropy ka, tapos dito naman, may ano ka, meron kang enthalpy na constant, di ba? Tapos meron ka ditong pressure, no? Constant naman. Ito naman ay may enthalpy ka kasi tumama dito sa ano sa saturated vapor o makakuha ka dito kasi may entropy ka dito eh. Entropy is constant, tatlo-tatlo na yung mga data mo. Makakuha ka diyan. So ibig kong sabihin, makakakuha ka ng mahahalagang punto ng tinatawag na ano uh, na mga values ng thermodynamics, which is yung enthalpy, di ba? Kasi mahalaga yan sa calculation natin, yung mga enthalpy. Kasi diyan mo kukunin yung mga work of compression. Maliwanag ba, class? Ano ang makukuha dito? Enthalpy 1. Saan yon? Ito, yung mixture. Ngayon, ano makukuha dito? Enthalpy 2. Ano naman yon? Yung enthalpy sa gaseous. Because saturated yon. Bakit saturated? Tumama sa linya. Eto, makukuha ba ng enthalpy rito? Makakuha, enthalpy 3. Kasi, ano, meron kang constant entropy. Di ba? Ayan, no? Itong linya na to, yung linya na yan ay constant entropy. So, pag may constant entropy ka, no, so makakuha ka ng enthalpy doon sa pressure enthalpy line. Now, bakit mahalaga yan? For example, yung work of compression, di ba yung work of compression is ano lang naman yun, M times delta H, di ba? M delta H yung work, no? So, M, tingnan natin ang unit, flow rate, no? Mass flow rate ng refrigerant is kilogram per second. Yung enthalpy naman is kilojoule per kilogram, di ba? Kasi specific enthalpy yan eh, na for every ano to. So, ano nakuha mo? Cancel yung kilogram, cancel yung kilogram. Kilojoule per second. Ano nga pala yung kilojoule per second, class?
Kilowatt.
Kilowatt, di ba? Eh, di ba yung kilowatt, sabi ko sa inyo, measurement ng power, di ba? Kilowatt, horsepower, BTU per hour. Ano yon? Sa refrigeration yon, pwede mo i-convert ng torr. Ano yung torr? Tons of
Tons
refrigeration,
of
no?
refrigeration.
3.52 kilowatt bawat isang tons of refrigeration, no? Cancel yung kilowatt, cancel yung kilowatt. So, pag nakakuha ka ng kilowatt mo, base dito, dahil nakakuha mo yung, di ba? Delta H is just ano lang, no? Mas mataas. Saan mataas yung enthalpy? Sa enthalpy 1 o sa enthalpy 2? Ah, sa enthalpy 2, di ba? Mas mataas yung ano eh, mas mataas yung pressure, mas mataas yung energy, mas mataas yung temperature, no? So pag sa formula, work equals mass enthalpy 2 minus enthalpy 1, ibig sabihin enthalpy ng saturated vapor Hg, ito naman ay mixture, no? HFG. Ayan, no? Dito, nasa gitna siya eh, may dryness fraction siya eh. So H1 yon. Ang saturated, ito, no? Ay, sorry. Ang work of compression pala, ito, dito, no? Yan. Ito yung sa evaporator, no? Refrigeration effect. Ito ay sa work of compression. Kasi etong linya na to ay compressor ang involved dito, no? Compressor. Okay? So, makakakuha ka ng work of compression. So, pag nakakuha ka ng work of compression, makakapag-solve ka na ng ano, ng tinatrabaho ng iyong compressor, 'di ba? Ayan oh. So ito ang work of compression, nangyayari yan dito. Yan, 'di ba? Kasi ito ay compressor, 'di ba? Compressor. Pag sinabing compressor, constant entropy. So yung pinakamataas niya na energy nandito sa point na to, which is superheat. Ang sa pinanggalingan naman niya yung tinatawag na entrance ng compressor, nandito siya sa curve, saturated siya, so meron siyang Hg, no, sa curve, Hg, ito naman yung superheat, no? So pag pinag-minus mo yan, makakuha ka ng work of compression pag sabihin mo ay pinag-ano mo yung delta H, di ba? Delta H, di ba? Work of compression. Ibig sabihin, kung sabihin mo ito yung 2, no? Ito yung 1, depende sa pag-number mo, MH2 minus H1. Ano yung H2? Ito yung dito, yung enthalpy dito. Makukuha mo yan dito kasi may constant entropy ka, no? Pinanggalingan naman ng galing sa vapor. Ito naman vapor, Hg, makukuha mo yan, no? Kasi meron kang pressure na ibibigay dito, no? May pressure ka diyan, tapos tumama ka sa doon sa saturated, no? So makakakuha ka ng Hg, di ba? So Hg, yun yung Hg is H1. H2, di ba? H2, ito naman yung superheat, no? Makakakuha ka ng superheat dahil meron kang constant entropy, no? Constant entropy line. So dito, pag meron kang dalawang points, makukuha mo na yun. Ngayon, if you want to check the work of compressor or work of compression, yun yung trabaho na ginawa ng pagko-compress mo sa refrigerant. Sa nangyari yon? Ito lang, no? Wala naman tayong iba. So, ito yan. Ano yon? Work is mass times enthalpy, di ba? Delta H. So, ito is M, sabihin mo ng H2 to, no? H2, sabihin mo H1 to, no? In this case, magiging H2 minus H1. Ano yung unit ng mass? Kilogram per second. Ano to? Pag pinag-minus mo, kilojoule per kilogram. Ano nangyari sa kilogram? Cancel. Ang natira ay kilojoule per second. Ano yung joule per second? Ano yung joule per second? Watts.
What?
Tapos yung K, prefix, means 1,000. Di ba? Kilowatts. Ngayon, yung kilowatt na nakuha mo, bilang work ng compression, pwede mong i-convert ng tons of refrigeration. There is 3.516 kilowatt for every ton of refrigeration, no? Pwede mo nang gawing 2, 3.52, no? 61, no? No, ibig sabihin, pwede mo nang i-round up ng 5 to na. 3.52 kilowatts, cancel yung kilowatts cancel. So, tons of refrigeration na lang to, no? Tons of refrigeration. Nandun naman yung conversion yan, nasa lahat. Nasa internet, sa tayo. Okay? So, natuto ba tayo? May natutuhan ba tayo sa pressure enthalpy class? So, ang pressure enthalpy ay pressure at enthalpy configuration ng refrigerant, no? Anong pressure to? High pressure. Ano to? Low. Saan nangyayaring low? Saan nangyayaring low? Saan?
Evaporator.
Evaporator. Saan nangyayari yung high pressure?
Condenser.
Condenser. Pag eto, dumiretso kasi constant enthalpy. Ito yung enthalpy, oh. Constant enthalpy, pababa, no? Pare-pareho lang. Habang bumababa ang pressure, habang bumababa ang pressure, habang bumababa ang pressure, habang bumababa ang pressure, constant lang yan, no? Diretso lang, oh. Constant lang ang enthalpy. At ang pag sinabing constant ang enthalpy sa thermodynamics ay adiabatic ang process dyan. Saan nangyari to? Anong equipment? Anong equipment to? Pag bumababa ang pressure ng refrigerant,
Expansion.
expansion valve. Bumababa ang pressure. Tingnan nyo ha, bumababa ang pressure. Ang kabaliktaran niya, tumataas ang pressure because ito ay compressor. Dito,
Compressor.
ano tong equipment na to? Ano to? Evaporator. Nagpapasok ka ng heat. Dito naman, kabaliktaran, no? Ano to? Kabaliktaran? Naglalabas ka ng heat, no? Heat rejected, condenser. Heat in, heat added, evaporator, no? So, yan ang essence ng pH diagram, no? So, mahalaga yan sa pag-solve ng refrigeration at air conditioning. Pag hindi nyo alam yan, hindi na tayo makakapag-solve ng ating problem, no? So ngayon, dahil time na, ang gagawin natin, no, isasubmit sa Lunes ng gabi hanggang Lunes ng gabi or bago magklase sa Martes at magkakaroon tayo ng recitation, no?